Okay, so I had promised you that I would make a video for what I always do in class with you the day before an embedded assessment. So we are going to go through what your book has in the embedded assessment versus what you are going to see on the printed version here. So this is on page 509, so you're going to want to make sure that you have your Springboard book turned to page 509 so that we can compare these things. We want to make sure that you make these notes for yourself so that you know what to expect when you come in to take your embedded assessment tomorrow. So, first thing that's true is that some of these are going to be separated because if you notice in number 1, part A, it really asks 3 different questions. Part B asks a question, and then part C asks 2 different questions. So what's going to happen on your actual typed version is that those are going to be separated. You can see it here. So number 1 is going to be separated into 3 different questions. So it asks, how many degrees would an hour hand travel between 7 and 9 o'clock? How many radians would it travel? And what portion of the circumference is that arc? So that's all the exact same questions that were there, but those are going to be separated into parts 1, A, B, and C, which means then that the question that is asked in part B becomes part D on here because we've already done A, B, and C. Also, we went over this when we unpacked, but I'm going to say it again. When it is asking how many linear feet of garden edging, this is asking for a distance. Whenever it is asking for a distance on the edge of the circle, that means that it's asking you for arc length. So we talked about arc length in the first 2 sections, I believe, 31.1 and 31.2. The formula that we came up with for arc length is S equals R theta, where theta has to be in radians. So notice that the first previous parts of the question, it did ask how many radians. Notice that the picture that they've given you looks eerily similar to the unit circle. Now notice it only has 2 marks in each quadrant as opposed to 3. Notice that those marks are equally spaced, which means that if you're taking each quadrant, this whole thing we know is 90 degrees, that each of these little sectors of that are equal to each other. So that should tell you very easily how many degrees each of these sectors are. So when it asks you how many degrees would an hour hand travel between 7 and 9 o'clock, it's essentially just asking you what's the measure of this angle. And so it asks you what is that in degrees. And from your memorize list, you should then know what that is in radians. What portion of the circumference just basically means this part, what portion of the circumference is between 7 and 9 o'clock, that's just asking you how much of the whole circle is it. So is that angle? So that's all it's asking there. Part C, again, we want to set the unit circle up, Please, again, be careful. Notice there are no middle marks here. So when you're lining things up, make sure you're not using the marks that are in the middle of each quadrant, but it just wants you to list the coordinates, which are ordered pairs, of where 7 o'clock would be on the unit circle. And then it asks the same thing for 9 o'clock, so the ordered pairs. All right, moving on to number 2. It says the architect wants to locate a stone rabbit on the edge of the clock wherever x equals plus or minus 0.6. How many stone rabbits does she need? What are the coordinates of the locations? So, first thing, again, just like I did in number 1, because I found in the past, sometimes when we ask multiple questions together, students forget to answer a part of it, and we don't want that to happen. I want to make sure you answer all the questions. So you can see here's the typed version. Oops. And on the typed version, it gives you the same thing, but it asks how many stone rabbits does she need first? And then I give you an additional hint, but I'm still asking you to find the coordinates, the ordered pairs. It asks you to show your work. Notice that I am telling you that on this part of the question that you need to use the Pythagorean identity. Notice that here I kind of clarified. When it's asking how many stone rabbits does she need, we said we're going to place one wherever x is plus or minus 0.6. So that's just asking how many different places are there in the coordinate plane or on the unit circle where x equals 6 or x equals negative 6. And again, this is just the x coordinate. So how many are there? So on here, for this part, what are the coordinates of the location? For that, we are going to use the Pythagorean identity, which the Pythagorean identity is what we did in section 33.1. That's sine squared theta plus cosine squared theta equals 1. Now, you may say, how am I going to use the Pythagorean identity? Remember that each coordinate, x and y, has a relationship in the unit circle. You should know what the x coordinate gives you. You should know what the y coordinate gives you. And if you don't, then you definitely need to watch the review video for these sections, or maybe some of the previous videos as well. But these x coordinates tells you something related to these, which you can plug in and then be able to solve. So you're actually going to write out however many stone rabbits they need. You're going to write that many ordered pairs in the second part of the question. All right, number 3, we're talking about Mahesh walking around the completed floral clock. It says he starts at 3, walks counterclockwise around the clock 3 times, then continues walking to 10 o'clock, and then stops. So, again, they're giving you a starting point, which is 3 o'clock. They're saying he's going to go around 3 full times, and then he's going to walk till he gets to 10, and he's going to stop. So that is really giving you the sketch of an angle, this description is. So you should be able to figure out how many degrees that is and how many radians that is. Again, on the typed version, those 2 questions are separated so that you don't forget to answer one. The next question says he's 45 feet from the center. That's giving you a radius. It's asking how far he walked, which is a distance. So 45 feet, it's telling you, is the radius. It wants to know how far did he walk, which again is going to be an arc length. So same thing that we talked about in 1B. We're finding an arc length there given the radius, And in part A, you already found how many radians that was. Now, the angles that you listed in the first part of the question are both bigger than 360 degrees or 2 pi because we went around the clock 3 times. So it then is asking what angle that's actually on the unit circle, so between 0 and 360, is coterminal. So when he stops at this 10 o'clock, after he goes around, it's asking what is that stopping place on the actual unit circle itself. Remember that you're given a unit circle for this, so that should be a pretty easy thing to answer. So what angle between 0 and 360 is coterminal? What angle between 0 radians and 2 pi radians is coterminal? And then last thing for that part is what is the reference angle? And it wants degrees and radians. Okay. Then, so that's all on the front of your embedded assessment that you'll see tomorrow. Then on the back, we've made really a lot of adjustments on the back here. So again, you can see I'm not hiding anything about what you're going to be asked. This is exactly what you're going to see. So notice that I've given a lot of clarification. So number 4, how can he use 45, 45, 90 and 30, 60, 90 triangles to figure out the values of sine of 45 and cosine of 60? Notice this does not say use the unit circle. Do not explain how to find these based on the unit circle. That's not the point in number 4. In number 4, you're supposed to know those 45, 45, 90 and 30, 60, 90 triangles, which we used in section 32, 2, I believe. So, again, notice I put exact answers, no decimals, which means you can't type it into the calculator. Giving me that is not going to give you any credit. No credit for decimal answers. Please make sure you explain how you can use the triangle. Even if you give me exact values, just giving me those is not going to give you full credit. You have to explain because it says how can he use. So again, the question, same as this, but I added some clarification for you. Number 5, we changed the wording entirely because we just found that in the past that people did not understand what this was trying to say. So you probably want to cross this out on number 5 and write down exactly what I have on this typed version. So number 5, we are changing so that the directions say, Evan encountered a problem asking for tangent of pi over 6. So on his quiz, because it's talking about he's taking a trigonometry exam and he's not allowed to use a scientific calculator, meaning he can't use a calculator that has sine, cosine, and tangent buttons. So when it asks for tangent of pi over 6, he can't just type it into a calculator. He needs to explain how you need to explain how he can figure out the tangent of pi over 6 using just a unit circle and our ASTC. Remember, ASTC is the All Scholars Take Calculus, which tells us what is positive in each of the quadrants. And again, that's all in the review video if you don't remember ASTC. So again, key word is explain. You have to actually write some sentences here describing how to find this value. Make sure that you actually do state the value. So what does the tangent of pi over 6 equal? Again, it needs to be an exact value, not a decimal, because he cannot use a calculator, only the unit circle and ASTC. On number 6, again, in the book, it says explain how he can use his chart. Again, people didn't understand the chart thing. Notice also that in the book, there's a part C and part D. On your typed version, there is none of that. So just part A and B are all that you're going to be asked. And it says explain how Evan can use only his unit circle and ASTC to find the following. Then find the exact values. So yes, you are supposed to say what sine of negative 45 is equal to, but you have to explain in words how you're getting the answer. Just writing out work is not an explanation. You do need words for both of these. Finally, when you look at 7, there's 5 different parts. We are only doing part C. So when you look at the typed version tomorrow, it just has one question. Given that the secant of 18 degrees is 1.05, explain how Evan can use reciprocal identities. That's what we did in the very last lesson to find the value of cosine of 18. So it's basically saying how is secant related to cosine, and you want to use that. Again, keyword is explain. You need some sentences here. Here I'm reminding you in the directions that it says that Evan's not allowed to use a scientific calculator, which means you can use, a 4-function calculator, but he doesn't have a cosine button. So please, in your explanation, don't say he types in cosine 18 degrees and enter, because he can't do that. It says right in the directions way up here, scientific calculators are not allowed on his exam. So you have to explain how he can just use a standard calculator without that cosine button and this knowledge right here, reciprocal identities, to find the value. You will have to use your calculator to get the answer, just like your explanation. And it does say round to the nearest hundredth. So all of these other ones are exact answers. So number 4, 5, and 6, all exact answers. Number 7, you're rounding to the nearest hundredth. Okay. So that covers what you're going to see on the embedded assessment. Make sure you also check out Google Classroom or actually I'll probably send it on Remind. So if you're not on Remind, you really should be. But I will normally before a quiz, I write out, what's on the non-calculator part, what's on the calculator part. And so I'll still do that for you and send that out on Remind and Classroom.